Now in this video I'm just gonna talk about rates. This is basically under application of derivatives. So let's read this problem and see if you can be able to solve it. Now here it says that the leakage of water on a tap is dependent on the volume of water. Suppose we are given a function L at v equals minus 3 plus the square root of v squared plus 9. Now, if the volume changes at a rate of 0.25 liters per second, how fast is the water leaking if v equals 4 liters? Now, the first step on this is to analyze what's given, and if possible, try to write that in differential form. Now, let's see what's given. Here we have a rate at which the volume is changing. That means we have dv over dt. This is provided to be 0.25. This is provided to be 0.25. And it's further given that v equals 4. Now the first step you're going to do here is to differentiate this with respect to time. You already know that you have to differentiate that with respect to time. Now derivative of L and V will just be dL over dt. You can still say L and V, it's still fine. Then you'll say dL over dt. This will be the derivative of minus 3, it's 0. So you're going to have to derivate the square root of v squared plus 9. Now when you derivate this, you're going to have 2v over 2 the square root of v squared plus 9 dv over dt. So you're going to have a formula like this. Now you're just going to plug in the values dv over dt as 0.25 and v as 4. So plugging that in, you'll get the dl, which is what we are looking for. We are looking for how fast is the leakage when v is 4. So we are looking for dl over dt. So we're going to have dl over dt to be 2 v is 4. I'm going to have 2 into 4 squared, it's 16. So you're going to have 16 plus 9. And this one is 0.25, which is the same as 1 over 4. Now, the 4 and 1 over 4 will cancel. The 2 and the 2 will cancel. And then you're going to have 1 over the square root of 25. Then you'll have dl over dt is equals to 1 over the square root of 25, which is the same as 1 over 5. So that's dl over dt. That's how you can answer this question, which you can convert to 0.2 liters per second. And that's the leakage. 0.2 liters per second. That's how fast the leak. That's how fast the leak occurs. Now the next question, I'm just gonna do this one, which is similar to the first problem. But now you can just pause the video and see if you can be able to solve it. Now water is being poured on a large cylinder container with a radius r. Suppose the volume of the water changes at a rate of 1 liter per second. Now you write that down. The volume of water changes at a rate of 1 liter per second. So that means you have dv over dt equals 1. Now, further continuing on this, and they say the radius is a constant. So if a radius is a constant, you already know that dr over dt is 0. That means we can treat r as a constant. We don't need to differentiate r since it's a constant. Now, what radius will the height of the water level change at a rate of 3 centimeters per second? Now, you're going to have to know the formula for volume of a cylinder. This will be pi r square h. Now, these are constant. These are constant. Pi is constant, r squared is constant, and we have h there. Now we're looking for the radius. You're solving for radius. Now the last statement here, it says that dh over dt is equals to 3. That's the last statement there. That's what the last statement says. Now I'm going to differentiate that. I'm going to have dv over dt is equals to pi r squared is a constant. Then I'm going to have to differentiate h. The derivative of h is 1, but you have to show that you were differentiating h with respect to t. So that's your formula. That's what you have. Now you're just going to plug in the values. You have dv over dt equals 1. Then you have pi, and then you'll have r squared, which is r is the variable that you're looking to solve, and dh over dt is 3. dh over dt is 3. Now you can just simply divide both sides by 3. If you divide both sides by 3, you'll have pi r squared equals 1 over 3. You'll have pi r squared. You'll have pi r squared equals 1 over 3. Then from then you can then divide both sides by pi. Then you'll have r equals 1 over 3 pi. R squared will be 1 over 3 pi. Then you can take the square root on both sides. Now the square root of 1 is 1. And you'll have the square root of 3 pi centimeters. So that will be the radius that will allow the water level height to change at a rate of 3 centimeters per second. And that's how you can solve such questions. That's how you can solve this. Now in this problem we have two cars, one traveling north and another traveling east, depart from the same point. If the cars east depart from the same point, if the cars travel at the same speeds, 12 meters per second and 16 meters per second, how fast are the cars moving away from each other after 6 seconds? This question is the same as just asking how fast is the distance between the cars changing after 6 seconds. So I'm just gonna show you here. I have one car traveling north and another one traveling east. So I'm just gonna do this. Now we have this distance. There will be a distance between the two cars, and then we'll have y and x. Now from this we can derive that d squared is equals to x squared plus y squared from Pythagoras. Then we're going to differentiate everything with respect to time. So in this case you'll have 2d. When you differentiate this, you'll have 2d. I'm just going to have this dt. This will be the same as 2x dx over dt plus 2y dy over dt. So that's what you're going to have. Notice that the 2's will just cancel, and you'll be left with dt is equals to x dx over dt plus y dy over dt. Now, okay, let's go back to the question here. Now the speeds of the cars are provided 12 and 16. They were provided 12 and 16, so I'll have 12 for this one and I'll have 16 for this one, or you can choose the other way around. It was not really specified in this question. Now, provided that you have the time here, it's provided 6 seconds. We know that distance equals speed multiplied by time. Now this car here, it's moving at 12 meters per second, so you'll have 12. You'll have y equals 12 into 6, wherein you'll get 12 times 6. 12 times 6, you'll get what? You'll get 72. And now it will be in meters, because like we know that we were having 16 meters per second. That already tells you your units. That's your y. Similarly, you can get x. So we'll get x equals 16 multiplied by 6. You'll get 16 multiplied by 6. Now 16 is the same as 8 times 2. Then you have that times 6. Now 2 times 6 is 12. You'll have 12. And 8 is the same as 4 times 2. Now 4 times 12, that's 48. Then you have to multiply that with 2. Then you'll get that this will be the same as 96 meters. Now you have x and y. That means that you can be able to get d then. That means you can be able to get d. Remember, I have d there. That means you'll be able to get d. Now what are we solving? We're solving d over dt. How fast is the distance changing between the cars? Then you'll have d over dt. This will be the same as you divide by d. So you'll have x dx over dt plus y dy over dt. This will be the same as your x, it's 96, and then dx over dt, this is 16, that's the velocity. We'll have, or the speed in this case, 16 plus, or y, it's 72. Then dy over dt, this will be 12 in this case, so it will be 12. Then you divide by d. In this case, d will be the square root of 72 squared plus 96 squared. Then from then you can then further simplify. I'm not going to do that in this video. But then basically this is your approach to rates. This is the application of derivatives. So this will be the rate at which the cars, or the distance between the cars, is changing after 6 seconds.